And now, Quan is going to talk about our software design.
Thank you, Ben. The hardware design is important, but also the software design. So, as you know, all the current like devices nowadays require like software to operate. So our system also consists of a server and a client. The firmware of the server is developed in C++ language and compiled with a free tool from a junior website. Once the microcontroller is started, it's wait for the EDAC system to be ready, and then it create a TCP server and wait for any request of connection. In the meantime, it will display the battery voltage and the status of connection. Once it accepts the connection, it will decode the message sent from the laptop, and depends on the type of the request. It will control the car, either control the car or reply the voltage measurement back to the client. And now I'm going to explain about the client computer, the software. It's running on the computer and it's compiled with the Visual Studio C++. And with the help of the 3D, the Xbox 360 controller, this will try to connect to the car. Once it connects, it will request for the calibration data from stored on the car. Once it got the data, it will start sending the control data to the car. At the same time, it will the data system and the camera will start streaming pictures and sensor data in real time back to our software. Our software will analyze it and then render with the real-time image obtained from the camera, and then display it on our GUI. As you can see, this is the microcontroller flowchart. It's just a simplified of the flowchart we currently have on the card, and also the flowchart of the software we implement on the laptop. As you can see, this is the snapshot of our GUI display. It gives you the sense of like how fast you go, the direction, and the view of where you are heading to. And also these lines over there will move up and down. This will also show you how many degrees it's pointing up or down, and the angle it's rotate. It gives you like how the roll of the car. And now Paul will talk about the testing.
In order to test our system to make sure it works, we have three major tests. First is the vibration of the control. In order to get a better control, we have to smooth out the control. Second is test the amount of time for system to get ready so we can use for data. Third is to test the distance of the new system compared to the old system. As you can see, this is a diagram of the speed we took for compare with the new system and the old system. Here's a diagram of the new system. For acceleration, in order to get better smoother control, we have reduced the instantaneous speed. So is the deceleration as well, as you can see, compared to the analog one. This is the times needed for us to set up the system. Originally, the system takes about 31 seconds to get ready. With our new data system, it takes probably about 33 seconds, which is 2 seconds more, but we can implement a lot more features onto the car. finally is the distance of the control. As you can see, this is actually a diagram we did testing during log K. This is the original system, which is running about 140 feet. And this is the distance with the camera feed, which is running all the way from K-Log to the end, almost the beginning of J-Log, with the 0.12 miles, which is about 630 feet. And without the feedback of the camera, we can get the distance even further away, which is 900 feet, which is 6 times further than the RC control. This is some cost and labor we did for our design. As you can see, we spent most of the time doing implementing and testing and troubleshooting. We're actually ending up take the car apart 3-4 times to achieve what Army wants for our project. There's some contribution among our group members. And there's some lessons learned. One thing we found the most important is to find a good expertise person in your project to help you out. For us, a wireless system, we have Professor Yang here. Without him, we will never get wireless system to work, and our project would never gone this far.
We'd also like to thank the GMU faculty that helped us with this project, specifically Dr. Packowitz and Professor Michael Young for his research, and the United States Army Materiel Command, Scott Kilby, David Layton, and Matthew Costanzi for their support and help in this project as well. Thank you so much, everybody.